All right, formative 3. That means that we are halfway through our formatives for this unit. This one was kind of long and beefy. It had a lot of questions that they were asking in it. These questions will reappear on your summative, so it is really important that we understand these questions. So, number 1, Sam rode in a hot air balloon. After the balloon began its initial descent, it stayed in the air at a constant height for a while. Then it continued its descent towards the ground. The graph shown represents this situation. And notice this power standard 1.2 is really checking solutions in a problem, making sure they make sense within the context of the problem. So basically, it's saying that this question is all your explanation. So 1.2, I am looking for your explanation. Can you explain what's going on in the context of the problem with this graph? So we need to make sure that we're including our units. We're making sure that we're including what's going on. We're using SAM, hot air balloon, time in minutes, height from the ground in feet. We're using all those different pieces to fully explain our answers so that we get the full possible points on this question. So, part A, identify the independent and dependent quantities and their units. If you've been paying attention in last week's lessons when we first started talking about independent, dependent quantities, I told you that the x-axis was your independent, so your independent variable, and the y values were your dependent values. If you didn't remember that, you could have thought back, well, which one depends on the other? Or maybe you just kind of have it in your head that time is usually always the independent and you worked from there. Either way, hopefully we're able to get that independent was what? The time the balloon was in the air. And the units, how time is being measured, is in minutes. So if you only wrote time for this question, I marked off some serious points, because time of what? Time that you spent sleeping in hours, time it takes an ant to walk across the room in days, time it takes you to snap your finger in seconds. You need to be specific when you're explaining these quantities and their units. You had to include minutes for sure. So time the balloon is in the air in minutes is the complete answer that I'm looking for. And then for my dependent, I also want a nice, thorough, complete answer, just like we did for independent. So we're going to say height of the balloon from the ground, and what's the units? Feet. Okay. Part B, identify the domain and range. Domain and range is often really tricky for students. It takes a long time for some students to really understand what's going on. But domain is always your x values. So remember that. Domain is your x values. Range is your y values. So domain, x values, range, y values. Just kind of drill that into your head so that you have that. Okay, so domain, x values. What are our x values talking about? Well, our x values is our time in minutes. And our range is our y values. What were our y values talking about? It was the height from the ground given in feet. So we're going to go height in feet. And I know we didn't spend too much time going over domain and range this year like I have in past years, so I am really lenient on this answer. I do expect at least this for a 4. I will definitely give an opportunity for 5s on this if you want to take it a step further and give me the actual numbers that go along with domain and range. So my domain was time in minutes. Well, what x values were covered? We started from 0. My graph started at 0, and I went all the way to 50. Okay, so my domain is from 0 to 50 minutes. My range, how far up and down did my graph or my function go? Not the visual lined gridded graph, but my function, my line, this pink thing right here. Okay, how far up and down on the y-axis does it go? Well, we started at 0. Okay, we're looking at y values going up and down. Okay, so yes, my graph is here, my graph is here, my graph is here, and we stop halfway between 2,000 and 2,500, meaning we gotta find that halfway. 2,250 is that halfway point. If you didn't know that, you could have added those two numbers, 2,000 plus 2,500 divided by 2 to get that halfway point. So my height, the balloon has a range of 0 to 2,250 feet. Okay, so this part right here would be your opportunity for a 5 on this little part here. All right, and then part C, is this graph discrete or continuous? Discrete, remember, is dots. Continuous is you can put your finger on one side of the graph and trace the entire thing without ever having to lift up your pencil. So this one is continuous. Doesn't stop or have gaps. Would be a fine answer for that. Identify the maximum point and explain what it means in the problem situation. Okay, so our maximum point, the highest this graph ever goes, I'm going to change color to purple. So the maximum is this point right here. And remember, a coordinate is x, comma, y. So what's the x value? It is 0. And what is my y value? Well, we already said from before that it was 2,250. Okay, so that's my maximum point. 0, 2,250. Maximum point. Now we need to explain what it means in the problem situation. So 0 was an x value. What were my x values talking about? My x values were talking about time. So at 0 minutes, what was my y value doing? So y values were height from the ground in feet. What was from the ground in feet? The balloon. The balloon was 2,250 feet in the air, which is the highest the balloon would ever go. I don't know why I drew a parenthesis there. The balloon will never go past that maximum height. And then this last part, so many opportunities for a 5 on this part E. Is the graph increasing, decreasing, both increasing and decreasing, or constant? Explain your reasoning. Well, this problem actually told us exactly the answer for this one. So Sam rode in a hot air balloon. The balloon begins its initial descent. Descent means that it's going down. So we have decreasing. Okay. And then stayed in the air at a constant height for a while. So then we were constant. Then it continued its descent towards the ground. Descent, like we said, is decreasing. All right, so explain your reasoning. That's where your points are coming from, is explaining your reasoning. So we were decreasing height, or we could say the balloon was going down. Then we stayed constant, so the balloon did not go up or down. And then decreasing, balloon goes down to the ground. Okay, something like that would be excellent for a 4 if you are one of my overachieving students that I so much appreciate. If you want that 5, add in some units of measure. So add in specific heights, add in specific minutes, go a step further than my answer, which was a 4. Go a step further, and you can absolutely qualify for those 5s. All right. Determine whether each relationship represents a function. Explain your reasoning. Okay, so for this first one, this one is not a function. And then we need to explain why. So remember, a function has one x value and one y value. But for this particular graph, at x equals 2, this purple line is x equals 2. We have 2 y values. We have y equaling 1, 2, 3, 4, y equals 4, and y equals 0. Meaning if I plugged 2 in for x into an equation, like y equals 2x, y equals 2x. So I plug in 2 for x, y equals 2 times 2. And this function is saying, well, you could get out a 4, or sometimes maybe you could get a 0. No, you can't have that happen. You plug something in, you only get one answer out. The answer is 4. It'll never be 0. So this one's not a function. So for one x value, x equals 2, let's say, there are 2 y values. And specifically, it was y equals 4 and y equals 0. So not a function. The second one, which was a chart, this one, x equals -2, y equals 5. 1 to 4, 0 to 3, 2 to 4. Yeah, this one is a function. Because for each input, remember, x's are our input, y's are our output. So for each input, there is only one output. Okay, 3 and 4, these ones are quick, hopefully quick for you, easy, and then we're done. Okay, so circle the function types that have an absolute maximum or minimum. Absolute maximum or minimum. Okay, remember this was a minimum. This is a maximum that happened in, no, not linear, not constant, not exponential, linear absolute value, and quadratic. Circle the function types whose graphs are curves. Okay, that would be my quadratic and my exponential. Not my absolute value. Those are 2 straight lines. Linear function is 1 straight line. Continuous is a horizontal line that is straight.